Okay guys, so let's continue with section 3.6, quantitative information from balance equations. So from the statement, we have, on part A, we have the moles of sodium 2 SiO3. So we're trying to find the moles of HF. So you just have to follow the balance equations that you have on there. So from part A, 0.300 moles of sodium 2 silicon O3. So from this balance equation, we know that for each mole of this compound right here, we have 8 moles of HF. So 1 mole of Na2 SiO3, we have 8 moles of HF. So we cancel these units out and we get that this is equal to 2.4 moles of HF. So this one was really easy. Let's see part B. Part B says, how many grams of NaF form when 0.500 moles of HF reacts with excess of Na2 SiO3? So we start with the amount of moles that we have on the statement. So 0.500 moles of HF. We want to get to the grams of NaF. So we follow what we have on the balance equation. So we know that for each 8 moles of HF, we have 2 moles of NaF. Remember, we're following the equation in here. So 1 mole of NaF is equal to, we have to now get the molecular weight of NaF, which is equal to 41.99 grams of NaF. We cancel these units out and we get that this is equal to 5.25 grams of NaF. Okay, so now let's solve part C. How many grams of this compound can react with 0.800 grams of HF? So part C, 0.800 grams of HF. We have per 1 mole of HF, we have 20 grams, around 20 grams of HF. 1 mole of Na2SiO3, we have 8 moles of HF. Remember that we can do these relationships because we are following the conservation of mass, and this is a balance equation. So every time that you have to do a relationship to solve in order of a compound in the orders of moles of a compound, if we have on here that we have 8 moles of HF, we can relate it to either this product or either this product or whatever we need. So you just have to follow the numbers that we have for each of the reactants and products of the in the balance equation. So per 1 mole of Na2SiO3, we have 121.97 grams. So we cancel the units out, and we get that this is equal to 0.1695 grams of sodium silicon O3. Remember that this volume here, this is the molecular weight of this compound. Remember that in this case we have 2 atoms of sodium, so 2 times 22.94, this is equal to 45.88 grams. So for silicon we have 1 times 28.09, which is the same, 28.09 grams. And for oxygen we have 3 atoms of oxygen in this compound, so 3 times 16, this is equal to 48, which in total gave us 121.97 grams. Okay, so let's solve one more problem. This is problem 3.63 in your book. So the first thing that we have to do in this problem, part A, is balance this equation. So let's write it down here. Plus HLCl3 plus H2O. So remember that whatever we have on the reactants, it has to be the same to what we have on the products, right? So we see on here that we have one aluminum on this side, 2, 1 oxygen atom, 1 oxygen atom, 3, I'm sorry, on here we have 3 oxygens, because remember that this number right here multiplies whatever we have inside the parentheses. So 3 oxygens on here and 3 hydrogens on this side too. 1 hydrogen on this side and chlorine. Then we have 3 chlorines on here, and on here we have 1 oxygen and then 2 hydrogens. So in total on this side we have 3 plus 1, we have 4 hydrogen atoms, and then 1 chlorine atom, and then oxygens we just have 3 on this side, and then aluminum we just have 1. That's for the reactants. In the case of the products, we have 1 aluminum atom. For chlorine we have 3. For hydrogen we have 2 atoms, and for oxygen we have 1. So that means that we need to find a value that can multiply the reactants and the products to make all these atoms in the same amount. So we have different amount of oxygen in the reactants and the products, we have different amount of hydrogens and different amounts of the chlorines. So what about if we balance this equation? Let's see if this works. HCl, AlCl3 plus H2O. If we put a number 3 on here, so now we have 6 hydrogens in total on the reactant side, and then if we put a 3 on here to balance the hydrogens, that's suppose that we have to do the same in the case of the products. So we put the same value on here. 3 times 2, that's 6. So we have the same amount of hydrogens in this case for the reactants and the products. Let's see for the chlorines. We have 3 chlorines on here, we have 3 chlorines on here, 1 aluminum atom in here, 1 aluminum atom on this side. So that means that our equation is balanced already. So by using this equation, we're going to solve part B. Part B says, sorry guys, let me scroll down a little bit. Calculate the number of grams of HCl that can react with 500 grams of aluminum OH3. So we use the amount that are giving us on the statement of aluminum OH3. So we know that 1 mole of OH3 is equal to 78.001 grams. This is a molecular mass, guys. So per each mole of OH3, we have 3 moles. So 3 moles of 3 moles of HCl, right? So 1 mole of HCl is equal to 36.461 gram. We cancel all these units out. Grams per gram, mole per mole, mole, and we get the grams of HCl, which is equal to 0.71 grams of HCl. Okay, so now let's work in part. This was part A, so this was part C. Now let's solve part, this was part B. Now let's solve part C. Part C says, calculate the number of grams of AlCl3 and the number of grams of water formed when 0.500 grams of AlOH3 reacts. So let's see. So we have to get 2 answers for part C. Part C says we have 0.500 grams of AlOH3. So 1 mole of AlOH3 over, this is equal to 0.001 gram. So 1 mole of AlCl3 is equal to 1 mole. Remember that you just have to follow the balance equation. AlOH3 and 1 mole of AlCl3 is equal to 133, around 134 grams. So we cancel all these units out. Grams times grams, moles times mole, mole times mole here, and we get that we have 0.85 5 grams of AlCl3. Okay. Let's solve the other part of part C. 0.500 grams of AlOH3, 1 mole of AlOH3 is equal to 78.001 gram, and per each mole of AlOH3 we have 3 moles of water. So per each mole of water, H2O, this case, remember the molecular weight of water is equal to 18.018 grams, right? So if we cancel these units out, same procedure as before, we get that we have 0.346 grams of water. So now in part D says, show that your calculation in parts B and C are consistent with the law of conservation of mass. So basically we have to show or to prove that whatever we have in the reactants is the same that we got on the products. So from the statement, you know that we have, for the first reactant, we had 0.500 grams plus 3 HCl. This is equal to AlCl3 plus 3 H2O. So from part C, we got that we have 0.855 grams of AlCl3 and that we have 0.346 grams of water, right? So if we sum this out, this is equal to 1.201 grams. So in part B, we got that for HCl we got 0.701 grams. So let's replace the value here to see if that sum the same amount of that we have on the products. So 0.701 grams. We sum this out and we got that this is equal to 1.201 gram. So the same that we got, the grams that we got on the reactants is the same that we got on the products. So this is proving that the conservation of mass is actually true. Whatever we have on the reactants, it should be on the products.